All right, so now we're going to go over lesson 3.3, growing steps. So at this point, you should have submitted what you thought 1, 2, 3's correct answers were to be. So it says sketch the next step in the pattern. Well, I can't do that until I establish a pattern. So I see that this is a 3. I see that this is a 3 by 1 set of squares. So then I'm looking over here. I go up 1, 2, 3, 4. So this is a 4 by 2. Here I go 1, 2, 3, 4, 5. So this is a 5 by 3. So automatically I'm noticing that my step number is matching the number of columns. So if it's asking me for the next step in the pattern, step 4, I am pretty certain that I'm going to have 4 columns. Pretty sure I'm going to have 4 columns. So now I just need to figure out, well, what's going on with the rows? Well, as you see, it's going up by 1, 3, 4, 5. So it's easy to think that this one would be 6. That 6 would then be the next part of the pattern. So this gives me, now I have a 6 by 4. So a 3 by 1, a 4 by 2, a 5 by 3, a 6 by 4. So that is the next step in the pattern. Then it says, Kieran says it's growing linearly. Do you agree? Well, first of all, I have to recall what being linear means. And when I think of something being linear, I think of this. I think of an equation, a linear equation. And then that makes me think of slope or rate of change. And when we have slope, it has a constant rate of change. It's changing by the same number. We're going up and over by the same number each time. So let's see if that's happening. He says it goes up by 1 for the number of rows and up by 1 for the number of columns. So let's see if I agree. Columns 1, 2, 3, 4, that checks out. Rows 3, 4, 5, 6, that also checks out. But I'm actually going to disagree with Kieran here. And the reason for that is, yes, certain parts of this pattern, are going up by 1, but what we really care about is the amount of squares, right? So there are 1, 2, 3 small squares here. They're not going up by the same amount every time. So now I go from 3 to 8 small squares, so that means I went up by 5. I go from 8 to 15 small squares, so that means I went up by 7. I go from 15 small squares to 24, so that means I went up by 9. So as you see, it's not increasing at a constant rate each time. It's also increasing each time that it goes up. So therefore, no, it does not have a constant rate of change. So again, my answer is no, it is not growing linearly. And the reason it is not growing linearly is because the total number of squares does not increase by the same amount from step to step. As we just saw here, this one is going up by 5, now it's going up by 7, now it's going up by 9. So now it's asking about Jada and Diego. So Diego has this equation. I know that this is going to be correct because there are n columns and n plus 2 rows of small squares. So let me show you what I mean. So if I'm looking at step 1, well, that means that n is equal to 1. So I'm going to plug that in. 1 times 1 plus 2. This gives me 3. And that is the number of squares that I have there. Let's try it with 3. When the step number is 3, n is 3. 3 times 3 plus 2. Well, that gives me 5 times 3, which is 15. So that is also true. So then it's asking, so I know Diego is correct, and I can explain it this way, or I could go back up and explain it because there are n steps in my column, and then over here it's always going to be n plus 2. My step number times n plus 2. And we see that because 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, 4 plus 2 is 6. I know Jada is correct as well, and I can explain Jada being correct in a couple different ways. I know that if I distribute the n here, and remember, distribution is a type of multiplication, but everything on the outside of the parentheses has to be multiplied by everything on the inside, gives me n times n is n squared, plus n times 2 is 2n. So really, when we're looking at it, Jada and Diego have the exact same equation. They just wrote it slightly different. But it is literally the exact same equation. It's just that Jada's is more simplified. So if I said Diego is correct, I know Jada's correct.